Company installs 5,000 light bulbs, each with an average life of 500 hours, standard deviation of 100 hours, and a distribution approximated by a normal curve. Find the approximate number of bulbs that can be expected to last a specified period of time, and that period of time in 166 is less than 690 hours. Again, as you've probably gathered by now, I like to draw pictures. So you've got your original variable x. It's a normal distribution. The mean is 500, but you want to know the probability that it lasts less than 690 hours. So the x value that you want here is 690, and you want it to be less than that. So what you're looking for is that area right there. Well, as we've established by now, you cannot look up anything in the table unless it's a standard normal. That's not standard normal. So we have to convert it. So the first thing you want to do is convert that thing to a standard normal. Using the formula z equals x minus mu over sigma. And in this problem, mu is 500, that's the mean, and sigma is the standard deviation of 100. So you end up with z equals x minus 500 over 100. So you want to use that formula to convert these things to standard normal. When you finish, you will have a standard normal distribution, which puts the mean at 0. And the 690 is going to be converted to some z value. And you don't know what that is right now, but nevertheless, you're going to get some z value. And I'll just leave it unspecified right now, but you're going to get some z value. Well, let's see what happens. So the bottom line, again, whether you draw these pictures or not, the bottom line is this. The probability, which is what they asked for, that x is less than 690 hours, is the same as the probability that the standard normal is less than that number minus the mean, which is 500, divided by the standard deviation, which is 100. Well, that's the probability that z is less than, and 690 minus 500 is 190. And 190 divided by 100 is 1.9. So that value right there is really what that was. I didn't know it before, but now I do. That 1.9 is what z is. And we're looking for the probability to the left, the area under the curve to the left. Well, what is that? Well, we go to the table and we look up 1.9. To the left is exactly what the table gives us. So we go to 1.9. And we get that number right there, which is 0.9713. So about 97.13% of the area is to the left of that number. So again, if you have, oops, I need to zoom out, don't I? So again, about 97.13% of the area to the left. That means about 97.13% of the bulbs will last less than 690 hours. Well, if there are 5,000 bulbs and 97.13% of them last less than or equal to 690 hours, if you multiply 5,000 by 0.9713 with your calculator, you're going to get, and again, we're going to round this off to the nearest bulb. That's approximately, we're going to round it, it's approximately 4,857 bulbs. That should last less than